Welcome to ClickMyProject.com. Now let me discuss about deadline based resource provisioning and scheduling algorithm for scientific workflows on clouds. Cloud computing is rapidly improving the latest technology. It is a term which is generally used in internet. The technological trend has enabled the realization of new computing model called cloud computing, in which shared resources, information and software and other devices are provided according to client requirement at specific time, are provided as general utilities that can be leased and released by users through the internet in an on-demand fashion. Cloud Cloud computing involves the virtualization, distribution computing platform, and infrastructure, software, and web-based services. Load balancing is challenging issues in cloud environment. It is a process of distributing of load among various nodes of distributed system so that the better utilization of resources while also avoiding situation where some nodes are overloaded and some nodes are idle and underloaded. Many algorithms suggested to provide the better utilization of resources on the basis of on-demand service. Cloud computing is rapidly improving the latest technology. It is a term which generally used in internet. In existing work, the scheduling is method which specified way some means is assigned to resources that complete the work. In existing work, we are using FIFO algorithm for scheduling. FIFO algorithm works based on first come first serve principle. This algorithm not depends on size of population. The drawback of existing system is resource allocation is not improved in this approach. Cost of resource usage is more. In proposed system, we introduce particle swarm optimization to overcome the problem faced by existing algorithm. Particle swarm optimization is an population-based stochastic optimization technique. Particle swarm optimization aims to minimize the overall flow execution cost while meeting deadline constraints. Our heuristic algorithm is performed using CloudSim and well-known population difference sizes. The advantage of our work is, in our approach, we reduce the workflow execution cost. We also improve the resource utilization and increase the ideal data center. Now let me see the flow of the process. In our flow, that first of all we have initialize the number of data centers and brokers and number of virtual machines and cloudlets. After that, we have to find out the dependency between the cloudlet and find the optimal cloudlets that contains the minimum distance, and applying the particle swarm optimization algorithm. Based on scheduling algorithm, we allocate the resource and compare the existing and proposed work in performance evaluation. Now let us see the demo of our project. First of all, we have to run file1.java. First of all, enter the number of data centers. So this data center contains the data center name and number of machines and host ID, number of processing element, RAM and bandwidth, and enter the number of broker. So broker contains the data center broker and broker ID, and we have creating the number of virtual machine. So virtual machine parameter contains the virtual machine ID, broker ID, million instruction per second, and RAM and bandwidth. And enter the number of cloudlets. cloudlet parameter contains a cloudlet ID, broker ID, file length, and file size and output size. And we have to run the, after that we have run pso.java. In that process we have getting number of generation, that means the number of cloudlets 20, and number of virtual machines are 10, and the individual population of cloudlets, that means the cloudlet capacity is getted. Then we have run the pso2.java. In that process we have getting the cloudlet and the cloudlet size and VM and the task completion time, start time, end time, and deadline meet, and cost, and status of the deadline. And we have displaying the number of active virtual machine and idle virtual machine, and total number of process completed, and the total number of process that meet the deadline 13. After that we have run the pso3.java, that is the heterogeneous process allocation. In that process we have getting the fitness value of cloudlet and find the dependency between the cloudlet using the Euclidean distance. And we have combined the dependent cloudlets. This is the optimized cloudlet. That optimized cloudlet should be allocated to VM, and we have getting the start time and end time and deadline, and we have calculating the cost value and the status. In that process we have getting the total number of process and the number of deadline meet is 1. And we have comparing the evaluation of our process. And we have running the bar chart demo.java. This is the comparison between homogeneous and heterogeneous number of deadline meet. This is the comparison between the processing cost of homogeneous and heterogeneous particle swarm optimization. Thank you.